Guys, welcome back to Pinet Labs. In this session today, we are going to get the introduction to RESTCONF, which is another way of configuring automation, or we can say is another way of deploying automation. So today we are going to talk about RESTCONF and REST API. So let's get started without wasting any time and let's see what exactly these protocols are. When we talk about these protocols, they come under model-driven programmability. And as of now, when we talk about model-driven programmability, under model-driven programmability, as of now, we have discussed a lot about netconf, right? So now we are going to explore RESTCONF and REST API. When we talk about the differences between RESTCONF and REST API, we can say there is no such significant differences between them. They both work in a very similar manner, but it is the infrastructure on which they differ. When we talk about RESTCONF is used on devices like iOS XE, iOS XR, and NXOS devices. Whereas when I talk about REST APIs are used with controllers or the devices which are managed using GUI, the graphical user interface. So RESTCONF is used on iOS XE, iOS XR, and NXOS. However, when we talk about REST API, these are used with controllers or we can say GUIs. For example, the controllers like there are various controllers which comes under the SDN solutions, right? Like we have got ACI. And when you purchase ACI, you use Epic as the controller. Epic, which stands for Application Policy Infra Controller. This is your GUI, basically, which you use for managing the ACIs. Similarly, when you take the SD-WAN solution, vManager is the device which we use as the controller to interact with the fabric. And when we talk about XEXS, we get to see DNA Center as the controller. So these are some controllers which we use to interact with the fabric. And when we talk about configuring these types of controllers, it is going to be REST API, which we will be using. And when it comes to devices like iOS XE, XR, and XOS, it is going to be RESTCONF. Now we are going to take some examples from security devices. Like if I talk about ASA, Adaptive Security Appliance, the Cisco's firewall. It is a device which can be managed through CLI, can be managed through GUI also. When we talk about GUI, ASDM, Adaptive Security Device Manager, is the controller there. Similarly, when I talk about FTD, Firepower Threat Defense, FMC is the controller, Firepower Management Center. So all these controllers or all these GUI we will be managing using REST API, and the XR, XE, and XOS devices we will manage using RESTCONF. Now let's talk about some more differences, but this time we will compare all the three protocols, netconf, RESTCONF, and REST API together. So when I talk about these three protocols, which are first netconf, then RESTCONF, and then REST API. When we talk about these three, they differ on the basis of, first of all, transportation. Now the transportation used by netconf is SSH on port number 830. And when we talk about RESTCONF and REST API, they use HTTP for their transportation. They interact with the device using the protocol HTTP, not SSH. Similarly, when we talk about the data structuring language in the case of netconf is XML. Only XML, I would say. And when we talk about RESTCONF and REST API, we can use both XML as well as JSON. Then talking about the data modeling language. Data modeling language in the case of netconf is Yang, right? And in the case of RESTCONF also, it is going to be Yang. But in the case of REST APIs, there will not be any data models. Rather, there will be documentations specific to the controllers, which will define all the APIs. So we will get to see some documentations here, depending upon the controller you are trying to configure. So if we are configuring ASA, then we might have a different documentation than if we are configuring some other controller like vManager, then we might have a different controller. Then if I talk about the operations, so operations under netconf, we have observed three, which are get config, and then edit config. These are the three operations which work with netconf. But when we talk about RESTCONF and REST API, we get to see four operations. The first one out of which is get. Then we have post. Then we have something called as put. And finally, delete. Talking about these operations, get is basically used for fetching the configs. It is used to fetch the configurations from the device. When we talk about post, post is used for creating or pushing new configs. When we talk about put, put is used for modifying existing configs. Then when I talk about delete, delete is simply used for removing configurations. So these are the four operations which we observe when we use RESTCONF or REST API. Whenever you will fetch any detail from your device, you will be using the operation get. When you want to create new configurations, you will use post. When you want to modify anything which is already configured on the device, then at that time you will be using put. And finally, when you want to remove any configurations, you will use the delete operation. These are the four operations. Now they work, as I mentioned earlier, they work with the HTTP protocol. So in order to understand how RESTCONF or REST API operates, we need to also talk about the HTTP's request response model. We need to know how exactly HTTP works so that we can understand on what infrastructure we can deploy REST APIs. When I talk about request response model of HTTP, it works between a client and a server. Now the server can be any web server, right? And we use various browser applications like Google Chrome, Mozilla Firefox. Then we have got Safari, and then so on. So we use all these browser applications for creating the HTTP query, which we send on to the web browsers, right? So using this browser application, I can send the request or the query to my server. As a result, I will get a reply back from my server, which is going to be my response. So depending upon what query you have sent, you will get a response. Now, usually when we open our Chrome browser, we type down google.com. So what we are trying to fetch out is the web page of Google. And this is a request which we are making using the browser. As a result, server replies us back with the web page of Google, which is basically the response from my server. Now, we can understand the operations working in this scenario in the backend. For example, let's say you have some cloud storage, you have some Google Drive cloud storage on which you are uploading new configurations, or you can say you are uploading some new files. So in that case, the operation which we will be using there is going to be the post operation, right? And when you are modifying your pre-saved files, you are basically using the put operation. When you are deleting some files, you are using the delete operation. And similarly, if for example, I am trying to fetch out just some details, then at that time the operation will be get, right? That's how these operations work. Then when we talk about Cisco uses some other acronyms to specify these operations, which will work between the setup, this whole setup. Let's go back to the previous page. So here we have got these four operations, but Cisco uses some different names, I would say. In the terminology of Cisco, get will be known as read, post will be known as update. After that, I'm sorry, post will be known as create, put will be known as update, and then delete will be known as delete only. So we use the term CRUD here to identify these four operations. But as I mentioned, this is the terminology of Cisco. It is the same thing, but with different names. So in this way, basically RESTCONF works and REST API works, where you are using these browser applications and these four operations to interact with the server, and you get basically a response for the request which you make to the server. This is your request and response model of HTTP. Now, the changes which we will make here are going to be that the server will be replaced with a network device. So instead of the server, I'll put down some router or some controller to talk or to interact with. And these applications, these browsers will be replaced with Python. So instead of using Chrome browser or the Safari browser, I'll be using Python to create my query using the four operations which we have discussed: the get, post, put, and delete operation. And that is how it will work in the network, we can say infrastructure. The queries will be created with the specific details using Python, and then we'll get a reply from our router or the device which we are configuring. And this whole thing will work with the help of HTTP protocol. So in order to create the query also, in order to create this query which we will send using Python, we need to know what are the components of the query, right? Or what are the components of the HTTP request. So let's talk about that now. When we talk about HTTP request, it consists of four elements, which we need to understand here. The first one is method. The second one is URL. The third one is headers. And the fourth one is body. When we talk about the first one, the method is used to identify the operation. So it will specify whether you are using the operation get or post or put or delete. When I talk about URL is used for specifying the resource location. So resource locator is something which we can call the URL as, and it will look something like this. There's going to be values like this: HTTPS colon slash slash, then the IP address of your device, then slash RESTCONF slash data slash the name of the data model which you are using, and then colon the container name inside that data model information. That's how my URL will look like, out of which I can say this and this. This and this section is the static part, whereas IP and data model and the container name will change every time I configure something new. So we can consider this part as the static part and the IP and this whole thing as the dynamic part. That's my URL basically. After that, the next thing we have is headers. Headers are basically used in two ways. Either your header can be accept or it can be a content type header. The value to accept header or the content type header will be same in this case when we are using RESTCONF, which will be application slash yang hyphen data plus XML or JSON, whatever you are using for defining the body. So if I'm using XML, so I'll say application slash yang hyphen data plus XML. If I'm using JSON, then I'll mention JSON in the place of XML. But what is this accept and content type? So there are two types of headers. We can have the accept header or the content type header. Whenever you are fetching out the details from the device, we'll be using accept header. And when we are pushing the information to the device, we'll be using content type header. What is the benefit of this? So by using the header, you can basically tell the server about the type of the query. So if the header of my query says that it is an accept header, then my server will understand how to process the query and will reply me back with the information which is asked inside the query. And if the header is being specified as content type, then my server understands, okay, that there will be some sort of payload inside my query, which I need to process to make the changes or to reply back. Then lastly, we have this body. Body is simply the payload which we send onto the device, which can be either written in the XML or in the JSON format. These are the four things related to the query. Now, when we send a query, we should also expect some response, right? So the server is going to reply me back with the HTTP response. So let's see what are the components of HTTP response now. When we talk about HTTP response, it also contains four things. The first is the status code. Then we have URL. We have headers. And we have body. We already know what exactly URL, headers, and body is there for, right? The only thing we need to know is status code. Status code is basically something which defines whether your request was failed or whether it was successful. So the success or the failure of the request which you are making is defined with the help of status code. Now, when we talk about these status codes, these are of 5 types. So we can say there are 5 types of status codes. The first one is 100 series status code. Then the second is 200 series status code. Third is 300 series status code. Fourth is 400 series status code. And lastly, fifth is 500 series. When I talk about the first one, the 100 series status code, it basically is going to be an informational reply, which we might not observe in the case of network automation. But yeah, whenever your server wants to provide you with some sort of information, it will give it to you with the help of a 100 series status code. When you receive 200 series status code, that means it is the success of execution. So whatever you are trying to execute got successfully executed. At that time, you will get a 200 series status code. When there is a 300 series status code, that means it is resource redirection. Resource redirection happens when your resources are not available or you are getting redirected to a new IP address or a new location. We usually observe this also when we browse web. Sometimes when you open some website, you get a 300 series status code and you get a notification that you are getting redirected to a new URL. So that is basically redirection of your query to a new location so that it can get processed. After that, we have 400 series status code. These will occur when there will be client error. Who is client? Basically, client is the user, right? The one who is sitting on the PC and creating the queries using Python. So whenever there will be a wrong query which you will create, you will get a series, you will get a 400 series status code. Then lastly, when you get a 500 series status code, that means there is some server error. The query is correct, but the server is not able to process your query. At that time, you will get a 500 series status code. And that's how HTTP and RESTCONF REST API work in the comparison of netcon. Again, a quick summarization. RESTCONF works with some specified operating systems like iOS XE, iOS XR, and XOS devices. When we talk about REST API works with the controllers, or we can say GUIs, like APIC, like vManager, like DNS Center. Then some firewalls which we have with the GUI access are the ASA and FTD. Then when we compare all the three protocols together, netconf, RESTconf, and REST API, we get to see that the transportation in the case of netconf is done with the help of SSH, and in the case of RESTconf and REST API, it is done with the help of HTTP. Then the data structuring language, which is supported by netconf, is only XML. But when it comes to RESTconf and REST API, we have got both the XML as well as JSON. Data modeling language is Yang here, Yang in the case of RESTconf also. But in the case of REST API, we don't have data models. We will use documentations for interacting with the devices using APIs. Then in the case of RESTconf and REST API, we have got four operations: get for fetching configurations, post for creating new configs, put for modifying the existing configs, and delete for removing configs. Then this is the request response model of HTTP. So we can say this is the base of how HTTP operates. Your client creates a query, usually using applications like Chrome, Firefox, or Safari, or so on, whatever browsers we have available. You use such browsers to create a query and your server replies you back with a response. Using the same model, we will also interact with the network devices. In the place of server, we will have the network device, and in the place of these applications, we will have Python. Then in order to create the request, we need to understand the four components of my request, out of which the first one is method, which represents the operation which we are using, or we can say which represents the task which you are trying to achieve. Then URL defines where exactly your resource is located, which will have the IP address, the data model you are using, and the container name. Other than that, there is some predefined syntax which we have to specify. Headers basically are of two types, accept and content type. Accept basically is used when you are fetching configurations. Content type is used when you are pushing configurations. Then body will be the payload which we can write in the XML or JSON form. Lastly, when we get a reply contains four things, that is your status code, URL, header, and body. Status code are of five types: 100, 200, 300, 400, and 500 series. 100 series are the informational replies, which, as I mentioned, we will rarely see in the network automation. Then 200 series is the success of the execution. That is what we should be looking forward to. 300 series is resource redirection. When you get redirected to some new position or new IP address, that is the time when you will get a 300 series status code. Then 400 is when you have created some wrong query and there is some client error. And 500 series when your server is not able to process the query and it is the server error. So that's how the whole RESTCONF and REST API concepts work. Now, in the coming sessions, we will be trying out the practicals related to RESTCONF and REST API to understand this concept in a better way. But yeah, till then, this is all what we had to learn. So thank you so much. I hope you found this video informative. I'll see you in the next one. Till then, take care of yourself.